Welcome to Khetz Tutorials, and in this video I'll be covering mesh analysis. Now a mesh is a loop that does not contain any other loops. So I'm gonna just do an example. So let's say we have a circuit. Don't really worry about the circuit. So this is a loop, right? This is a loop, and this is also a loop. So if you look at the red loop, it has two loops in it. So it cannot qualify, or it cannot be called a mesh. We said a mesh is a loop that does not contain any other loops within it. So I'm going to erase that. So in this case, or in this circuit, we only have two meshes, which are the blue one and the black one. So after correctly identifying your meshes, you can continue to solve the problem. So let's say we had a resistor here, and we had a voltage source here, right? Vs. Let's call this R1. Let's call this R2. Let's call this R3, right? So now, doing mesh analysis, we are going to say, starting from this side, let's call this current I1. Let's call this current I2. So here's what's going to happen. Before we start, you can see that this R2 is shared between the two meshes. So there's something which you have to do. Looking at this top node here, this is I1, sorry. This is I1. It goes like that, so it goes in that node. So it goes in that node. This is I1 going in. And at this point, you have I2, which goes like that, which means it's going out. So I2 is going out. So here we can say this is going out as well. Let's call it I. The unknown current, which is going through the R2, right? So if you check, this means that I1 splits into I and I2. So you can say I1 is equals to I plus I2. So what is the value of I? Therefore, I is equals to I1 subtract I2. Okay, so we know this for sure. And we can continue forming our equations for each of the meshes. So you solve for each of the meshes and then find equations, and then those equations will help you to find I1 and I2. So continuing with mesh one. So in mesh one, let's form the equation. Starting here with the voltage source, we encounter it at the negative first. So we're going to say negative Vs. Coming to this point, R1. So R1 multiply. So basically using Ohm's law, which says V is equals to IR. So multiply the current in the mesh by the resistor value, or just take the voltage value if it's given as a voltage source or whatever may be the case. So we have negative Vs, we have plus R1, I1. Then we're going to say plus R2. And then at this point, you'll see that I1 is going down, which is the same direction as I, this I. And we said that I is equals to I1 subtract I2. So we're going to say R2, I1 subtract I2. And then that is all for this mesh. So you check all the elements, 1, 2, 3, 1, 2, 3, and then equate to 0. That is your first equation. Moving on to mesh 2. Now in mesh 2, let's start at R2. Now if you look at I2, it's going in the opposite direction of I. It's actually going up. It's going like that. So it's going up. So which is the negative of I. So if I is I1 subtract I2, then the negative of that is I2 subtract I1. So we're going to say I2 subtract I1 in the case of the second mesh, and move on to the final value in the same mesh, which is R3. So plus R3 is equals to 0. So this is just an example of how to form your equations in terms of mesh analysis. Now we're going to move on to a special case of mesh analysis. So again, I'm just going to draw a random circuit. So before we get to the final section of this, I only had a voltage source here, What if we have current sources? So let's have that there. Current source, let's call it IS. Then we have, let's say maybe you have a resistor there, and then the same thing, kind of like the same thing which we had. Okay. So if we have a current value here, and another current value here, let's call it I1 and call this I2. So as you can see, this current in the mesh is going in the same direction as the current source. And there isn't any other current on this side. So this current goes all the way like that. And then it splits into something, another thing there. It splits into I2 and let's say I. So before it splits, you can see that it's actually equals to this mesh current. So you can say IS is equals to I1 or I1 is equals to IS. And that is how you treat a problem like this when you only have a current source which isn't shared among any meshes, and you only have one current source or one current value or variable on this side or whatever side it may be. If it corresponds with that, then we're going to say that. But if it were in the other direction, which is which direction? This direction, right? The opposite direction. Then we'd say I1 is equals to negative IS because it opposes the direction of that. So whichever way you choose, it's always going to work out. Like always going to work out as long as you compensate for it using your signs. Okay, so now we'll move on to the final section of mesh analysis, tutorial. So, which is a super mesh. So let's say you have a case like this. This is just a random circuit, which you shouldn't worry about. This is just a random circuit, right? So let's say you have, okay. Let's close it off like that. And then at this point, you can put another resistor. It doesn't really matter. So let's say we have, maybe here there's a voltage source, VS. Let's say we have I1, you have I2, and I3 here. All right. So if you look here, let's call this IS. If you look here, you have a current source shared between two meshes. So the question is, what do you do? What do you do? Okay, so this will form, like in nodal analysis, this will form a super mesh, something called a super mesh. But in this case, instead of this omitting or taking away anything that is in parallel with it, like the super node did, what you do here is anything which is in series with the super mesh or the current source which led to a super mesh being formed, you take it out as well. So this resistor value here is taken out as well, and all of this is omitted, right? So at this point or at this node, you'll see that I1 is going in like that and it goes out. So I1 is going in that direction. And then here, I2 is going in, right? And finally, this IS is going in as well. So you can safely say that IS plus, this is I2, plus I2 is equals to I1, or I1 is equals to IS plus I2. And this is one of the equations which will help you to solve the problem. So you go down to a node, an easy node where you can identify all the currents, how they meet and how they split. And this is how you treat a supernode. So let's call this R1, let's call this R2, let's call this R3, right? So this is how you treat a supernode. So these two nodes, these two meshes, this is a super mesh, not a supernode, sorry. This is how you treat a super mesh. So these two meshes would eventually become one mesh. So you treat all of this as one mesh. So you'd first form this equation, or you'd first form this relationship between the current source and the two mesh variables. Then you'd move on to find the full equation of the mesh and any other meshes which you have. So this is how you do it. Starting from the voltage source here, you'd say negative Vs. And at this point, you'd say plus R1, then say I1 subtract I3, then say plus, coming to this point here, because all of this has now become one part, one mesh. So you then say R2 and then say I2 subtract, because we are now in this mesh. So use the variables as they are, even though you all of this is one mesh. So you can't use one variable because it will never work out. You still maintain the variables which are present in each of the meshes, but it now becomes one whole equation. You now combine everything. So it's going to be like that. And you're going to say R3I2. Then you're going to say, so that is 1, 2, 3, 4. 1, 2, 3, 4. So that is all. And then you equate to 0. This was just an example to show you how to deal with super meshes and meshes in general. And I hope this will really be helpful.